feedback here. I want some volunteers. How many show hands? How many people picked that plastic's a hero? None of you, huh? All right, so why? Give the reasons. Why is plastic bad? It doesn't decompose. And it's something that wasn't around on the earth until man invented it, right? Excuse me? What did you say? Okay. So we're going to make Halloween slime. First question for you guys. What type of material is slime? Is it a natural material? It's not natural. It doesn't naturally occur in nature. People make these big laboratories and industrial places to produce it, right?
Question is, what is it? Is it a solid or is it a liquid?
It's a synthetic material is what it is. Synthetic means that it's made... I can't hear myself think. Are you going to say this? Okay, so what does synthetic mean? It's made by the production of simple compounds that hook together to form larger compounds. And these compounds are synthesized in a laboratory. So slime is a synthetic material. And this is a particular type of synthetic material. So I want you to get the hang of what really is happening on a small scale. There are these single units, and you can think about them like cars in a railroad station. A monomer is one single railroad car. All right? But the cool thing about monomers is they can hook into other monomers and form these extremely long, basically trains or chains called polymers. And these polymers are synthesized, they're made in the laboratory. So what we're going to do is we're going to go and look a little bit more into monomers and polymers. Okay, monomer, just like the word root says. Do you know what the root mon means? One, like monocle, monotone. If you have the same pitch and you don't change your pitch, it's monotone, one pitch. So monomers are molecules made up of organic compounds with other monomers. So they hook together with themselves to make a really long chain. And if you have a whole bunch of monomers together, anybody know what that's called? A polymer. So a polymer is a substance that's made up of long chains. And what do I mean by long? Thousands or even tens of thousands of subunits are going to make a polymer. So really, really long chains. But you can't see the long chains because they're so small they're invisible to the eye. So if you have this train all the way across here around the room, that would probably be about the size of the length of the polymers that we're working with today. All right, so plastic. We know that it's not natural, it's man-made. It's all over the place now, right? There's plastic bags, there's plastic surgery. I could point to like hundreds of things that are plastic in this room. Here's a question for you guys. I want the answer in the show of hands. How old is plastic? What do you guys think? Is plastic, how many people think plastic's 14 years old? Okay, one. Okay. How many think it's 114 years old? A few more. 214? Okay, a few more. 314. Okay, pretty good spread in here. 414 years old? And a few. Okay, so you're sort of around in this area here. The crazy thing is that plastic's super new. It's only 114 years old. It was first made in 1907 by this guy named Bakelin. And he's the guy that invented the word plastic. Before he made that in 1907, nobody in the world had ever said the word plastic before. It didn't exist. So it's really new, and we've been producing so much of it on the earth that it's become a really large environmental problem. So we got to be careful what we make in the lab because it has repercussions. It can affect the way things are on Earth. All right? I want to do this quickly with you here as a little review. The polyvinyl acetate, which is the main part, the sticky part of Elmer's glue, has a monomer unit like this. And then these are hooked together. So I want you to use your previous knowledge and tell me what would be the formula for this monomer unit of vinyl acetate. How many carbons are there? 1, 2, 3, 4 carbons, right? So you'd write carbon in, where would you put the 4? Subscript, good. Yeah? All right. How many hydrogens? 1, 2, 3,
4, 5, 6.
6. So H6. And then how many oxygens? 2. O2. So this is the empirical formula. That's for one base unit. But like I said, these molecules are extremely long. If you were to count how many molecules are in, or how many atoms of this stuff are in a full strand of the polymer that's in Elmer's glue, that might be something like C4000, H6000, and O2000. So even though they have the same ratios, 4 to 6, 4 to 2, 4,000 to 6,000, 4,000 to 2,000, it's still got the same ratios, but it's an extremely long molecule. Okay? And what happens when you stir Elmer's glue, you can stir it all day. Is it easier to stir water or stir Elmer's glue? Water. Because water doesn't have as much resistance to your stirring it, right? And when you stir Elmer's glue, if you start stirring it and you stir it for like 10 minutes, is it gonna change how much resistance it has? Not really. It's just gonna be glue resistance, just like if you were stirring honey. All right. So even though it has a different resistance, what's happening when you're stirring Elmer's glue is you have these long strands of the polymer that are sliding like this, like your arms sliding against each other. That's why it's like, if you ever tried to stir a pot of spaghetti when it's cooked, it's got a resistance because these things are flowing all over the place, and that's forming a resistance to flow. All right? So, long molecules, like big, long spaghetti strands that are flipping and flopping on each other, but that's not slime. That's still a regular liquid. It's just more viscous. Viscous is a super important word that you should know for the rest going forward in chemistry. It means, literally, the resistance to flow. All right? So I got a question for you. Is it easier to stir honey when it's really cold or when it's really warm? Warm, right? So the higher the temperature is, the less the viscosity is, the less the resistance to flow. And that's called a regular or Newtonian liquid. Okay? So a Newtonian fluid is a liquid that only changes its viscosity when the temperature, or if there was like, if you went to a place where there's a really high pressure that's pushing on it, that can also change the viscosity. And that's water is a Newtonian fluid, honey is, Elmer's glue is. But it's not going to be after we do a little chemical reaction here. All right? And the chemical reaction we're going to do is we're going to mix it with borax. Now, borax is this molecule here. Quickly, let's